Hello friends, welcome back to this online seminar session which is by Adarsh College Hingoli. Friends, myself Aakanksha Chaudhari, I am studying in class B.SC second year from Adarsh College Hingoli. Friends, today I am presenting the ordinary differential equations method, which is the homogeneous equations in x and y. So friends, the equations are of the type dy by dx equals to f1 of x comma y by f2 of x comma y, where f1 and f2 are the expression homogeneous and of the same degree in x and y. Here dy by dx equals to f1 of x comma y divided by f2 of x comma y. Here we have the equation number 1. Then on putting y equals to v into x, then we have dy by dx equals to v plus x into dv divided by dx. Then the equation 1 becomes v plus x into dv by dx equals to f of v. Here f of v is the function of v. Then we have x into dv by dx equals to f of v minus v. This implies that dv upon f of v minus v equals to dx by x. Here the solution of v gives the relation between x and v, that is between y and y by x, which satisfies the original equation. So friends, here we have to see the example based on this method. So friends, here we have the example, that is x square plus y square into dx minus x minus 2 into xy dy equals to 0. Then the solution, here we have to put y equals to v into x. Then dy by dx equals to v plus x into dv divided by dx. Then x square plus y square into dx equals to here we have to moving minus 2xy dy equal to RHS side. Then we have x square plus y square into dx equals to 2xy dy. Then we have dy by dx equals to x square plus y square upon 2xy. Again v plus x into dv by dx equals to x square plus v square into x square upon 2x into vx, which is equals to x square into 1 plus v square upon x square into 2v. Here we taking x square as common. Then v plus x into dv by dx equals to 1 plus v square upon 2v. Then again we have x into dv upon dx equals to 1 plus v square upon 2v minus v. Here we have to taking the LCM. Then we have x into dv by dx equals to 1 plus v square minus 2v square upon 2v equals to 1 minus v square upon 2v. Here we have to separate the terms of v and x. Then on taking v and x common terms, 2v upon 1 minus v square into dv equals to dx by x. Then we have to take the integration. Then we have log of c minus integration of minus 2v upon 1 minus v square into dv equals to integration of dx by x. Here we have to modify this. Then we have log of c minus log of 1 minus v square equals to log x. Again log of c equals to log x plus log 1 minus v square. Then we have log of c equals to log x into 1 minus v square. As log of a equals to log of b, then we have a equals to b. Then friends, we have c equals to x into 1 minus v square. On putting v equals to y by x, as y equals to v into x, v equals to y divided by x. Then we have c equals to x into 1 minus y square upon x square. This implies that c equals to x square minus y square upon x, which is equals to cx equals to x square minus y square. Here we have the solution, that is x square minus y square minus cx equals to 0. Here we have the complete general solution of this example of the equations of the type homogeneous equations in x and y. Here x and y are variables and homogeneous means the same degrees. Thank you friends. Thank you for watching the video.
Friends, also I thank to Dr. Hatkar sir who giving this opportunity to us for presenting such seminar. So friends, thanks for watching.